Okay, now I want to talk about foci. Each ellipse has two foci, plural for focus as shown in the picture here. As you can see, C is the distance from the center of the focus, from the center of the ellipse to a focus. We can find the value of C by using the formula C squared equals A squared minus B squared. Like Pythagoras is C squared equals A squared plus B squared. Well, it happens to be for the distance between the focus. See how they have indicated right here from the center to the focus? That distance right there is not equal to the Pythagoras theorem. It's equal to A squared minus B squared. What is A? A is the major radius in the ellipse, and B is the minor radius. So it's just like Pythagoras, except it doesn't have a plus, it has a minus instead. So what I want to do is I want to draw circles in our ellipse that represent the foci. Now, here's what I have so far in the code, and let me just run it real quick and then I'll start explaining some things here. Okay, so you can see that I've drawn the two foci points right here. And let me just let it iterate all the way through this. Okay, you can see right here I have created some variables. Foci distance, and the foci 1x and 1y, and the foci 2, x and y. And I'll just say number 1 is on the left. Foci number 1 is on the left, and number 2 is on the right. So let's see here. Okay, so let's see, where do I? Here's my major radius and my minor radius of my ellipse, and here's my foci, the foci distance. Foci distance is equal to the square root of A squared minus B squared. So the major radius squared, major radius is 100 squared, and or A is going to be 100 squared, B is going to be 50 squared. So A minus B. So now that I know that, now because of this equation, I know what that distance is from the center of the ellipse to each foci. And I say the one on the left, foci number 1, x, is going to be equal to that distance minus 1. And the foci lie on the major radius, so y is going to be equal to 0. And foci number 2, which is on the right, is equal to that distance. So I draw circles from the center. Oh, I just draw circles at those points, okay? And I draw them in color 12 and 11, and I fill them for you. So that's what you're seeing when I run this program. You're seeing those two foci points right there, those two solid filled circles. Okay, let me just iterate through here. Now, what I'm doing is here I am. Oh, I should just comment this out. Okay, is that what I had in there? These are all points on the circle. Yeah. Okay, so I want to make that an ellipse instead. So instead of using radius, I'll use major radius and minor radius here. Okay, and save and run. Let's see how that goes real quick. Major and minor radius. There is my first point on the ellipse, and I want to know what is the angle of the line that goes from point 1, a point on the ellipse, to the first foci. It's 192 degrees. So the angle of this line is 192 degrees. Next, I want to know what is the angle of the line that goes from this point on the ellipse to the second, or the foci on the right. So let me press key on my keyboard, and its angle is, as it goes from this point on the ellipse to the second foci, is 294 degrees. The bisector is going to be somewhere right in the middle, somewhere between 192 and 294. And in fact, let me see if I can bring that up. Where is it? I got so many things open here. Where is my... Okay, so we have... Okay, I want to know the bisector, okay? Bisector. Bisector is going to be equal to whatever is between, equals what is between those two angles. So what is between 294 and 192? What is between 294 and 192? Let me just think real quick what that's going to be close to. So I know it's going to be, let me just bring up my calculator. Where's my calculator? Calculator. Okay. Alright, so 294 minus 192. 294 minus 192 equals 102. 294 minus 192 equals what? 102. 102. So I know that's the difference between those angles, and I want something that goes right in the middle. I want to be able to draw a line right in the middle, the bisector between those two angles. So what is 102 divided by 2? Is it 51? Yeah, equals 51. So the angle is going to be the lesser number. Which one is less? Between 194 and, or I'm sorry, between 294 and 192. Which number is less? 192. So it's going to be 192 plus 51, which equals what? Clear. 192 plus 51. 243. 243. So and the angle of this line that splits between the bisector, the angle of that bisector is going to be 243 degrees, or at least it should be, okay? So I'll just keep that right there. And as I iterate through here, there's the second point on the ellipse, and I want to know what is the angle between that line and the other line that goes from that point to the second foci. There's the line that goes from there. So those angles, the first line is 210 degrees, the next line is 330 degrees. So what is the angle between those? Let's see. That I could tell right off the bat. The bisector angle on that is going to be 270 degrees because it goes straight down. That's the easy one. And of course, the second point on the ellipse right here. What is the bisector between this line, the angle formed by that line, which is 245 degrees, and this line going over to the other foci? What is the bisector angle? That's what I want to know, is the bisector angle. For each point on the ellipse, I need to know what the bisector angle is. I just keep on going through them, and it goes all the way through the circle. So my goal is to get the bisector angle. Now, how do I do all of this stuff here? Let's see here. Okay, so as I'm going through my 4 next loop, I'm saying here's the value of x and y, which is a point on the ellipse, and I draw a little circle with a radius of 4, color 14, at that point on the ellipse, and I call that point 1 x and point y, point 1 y. And I call point 2 is foci number 1, which would be the foci on the left. And I say, here is the angle between point 2 and point 1. And if, of course, like before, if the angle is less than 0, then we just add 360 to it, so it'll come out to be a positive value. And that's where I was printing them, and this is where I was drawing a line from the point on the ellipse to the foci, point 2. And then I was sleeping, and then I did the second one. I did the same thing for the second one. Point 2 x is now going to equal the second foci. Point 2 y is going to equal the second foci y. What is the angle between point 2 and point 1? Point 1 hasn't changed. It's still, point 1 is still the point on the ellipse. And here is where I calculate the angle of that second line going down to the second foci. Once again, if the angle is less than 0, then just add 360, go ahead and print the angle and draw the line and sleep. And that's all I'm doing, is going through there. Every time that I go I complete these two right here, I need to know what the bisector angle is. So I need to add another variable here, and let's see, we will call this, instead of angle, we'll call it foci 1 angle and foci 2 angle. Okay, so here is where I go through this, doing the foci number 1, and here's where I get the angle. So I will say, right there, I will say foci 1 angle equals angle. And then down here I will do the same thing. Foci 2 angle equals angle. Alright, so now I have foci 1 and 2 angles, and I want to know if foci 1 angle is less than foci 2 angle, then bisector angle. Let me put another variable up here, sorry. Where is my variables? I'll call it bisector angle. I should spell it out. Bisector angle. Okay, bisector angle. If foci 1 angle is less than foci 2 angle, then bisector angle is going to equal F2A, foci 2 angle, minus foci 1 angle. divided by 2. Divided by 2. So whatever that is, I'm going to say foci 1 angle plus whatever half of that is. That's if foci 1 angle is less than that. And I should go like this. Cut. Else if what is this? I think this might be an else if case. Else if foci 2 angle is greater than foci 1 angle. Wow, I don't know how to do else ifs really. I'll just go like this. Copy. Paste. If FLA is not equal to not FLA, if F1A is not equal, because they could be equal to each other. If F1A is not equal to F2A, then tab over. That means that F2A is less than F1A, so it's going to be F2A, F1, and F2. F2 is less. Let me think here. It's going to be a problem with the 360 coming out. We'll see how that works out. Bisector 2. Let's see. Okay, bisector angle is equal to foci 2 angle plus half of 1 minus 2. Alright, and here is where I would put another else. Bisector angle equals F1A. It could equal F1A or F2A because they're equal. And then I will print end if, and then print bisector angle. Alright, and then that's where I'll do a sleep. Again. Okay, so save and run. Is it still running? Nope. Bisector angle. Oh, I don't know. FLA, Florida. F1A. Save, run. Bisector angle. What am I doing wrong? Bisector angle equals. Sorry. Okay, let's try this. Okay, so there's 192 degrees, and remember we had this notepad right here, 192 degrees, and the second one is the second angle going down right here. It's going to be more than 270. It's in fact 294, and the bisector angle is 243. Ta-da! Okay, so that's the angle, 243 degrees, and I want to draw a line. Okay, I want to draw a line next. So let me just make sure that all of these make sense. Oops. I'll keep on going through the rest of them. There's 210 and 330, and the bisector angle should be 270. 270. Voila. And there's 245, and the next one is going to be something close to like 340 or something. Let's see, 347, and the bisector angle between those two is 296. So somewhere around here is going to be 296 degrees. And 360. Now it's right here. That's the point on the ellipse, and we want to know what is the angle between that point and the first one. You can't see the line, but it's 360 degrees. Same thing as 0 degrees. And the angle between that one and the second foci is also 360 degrees. The bisector angle should equal 360. Voila! And here we have 114 degrees, and what is that going to be, like 23 or something? Let's see, 12. And the bisector angle is going to be something around there, so it should be something like 50 or 60. 63. Okay. And the next one, 150 degrees, 30 degrees. What should that be? The obvious answer is it's going to go straight up. That should be 90. 90. Voila. All right. And the next one from there is 167, and then up right here is going to be like 70 or 80, or 65. So the angle between there is going to be somewhere past 90. It's going to be maybe 120, 116. Okay. And then the last one right here is going to say, well, the angle is from here over is going to be 180 degrees, and the same thing for the second foci, and then the angle should be 180. Nice. And we're all done. Okay. So now that I know what those angles are, I want to draw, if I'm going to be drawn, if I'm going to be plotting a what do you call it, an offset. What did I have here at the top? I said shoot, maybe it's in here. Okay, plot a parallel inset and outset, which I call offsets. So I want to plot some points that the drill bit are going to follow that are outside the ellipse or inside the ellipse. So first we will do inside the ellipse, because it's the same angle. Alright, so let me go right here to my code. Oh, sorry. Okay, so am I drawing the lines here? Yep, I'm drawing from a line from point 1 to point 2 here, and drawing a line right there. So let me get rid of those, because I don't want to draw a line all the way. What I want to do, because I know the angle, I want to draw a line from the point on the ellipse. Draw a line from the point on the ellipse at F1A, at that angle, and the length with a length of the drill bit radius. So we need to add another variable up here, and let me just go like this. Dimension as double, drill bit radius, and I'll go ahead and set the drill bit radius right here. Copy that, Control C. I certainly hope I am recording right now. Doesn't look like I am. Oh yes, it is. Okay, so Control V. Let's say our drill bit radius is 20 equals 20 millimeters. And I want to draw a line at, let's see, let's go down here. The very first time that I draw a line, right there, after I figure out what the angle from the point on the ellipse, oh no, after, so I don't want to draw those individual lines. I want to, after I figure out the bisector, okay? After I know what the bisector angle is, here is where I want to draw a line from the point on the ellipse. Okay, so we will call, I know what the point on the ellipse is x comma y. Those are the points on the ellipse. Now I need to add another variable called dimension as double. This is called offset. Offset x comma offset y. Okay. So after I know what the bisector angle is, I say offset x is equal to the cosine of bisector angle. Copy, paste, and then times degrees to radians. That's what cosine needs. And then multiply that. Okay, first of all, this is going to be x plus, because x is the point of the x value of the point on the ellipse. So I have to add, I have to start right there, and from there I have to add whatever the value of the cosine is of this angle times the drill bit radius. And I need to do the same thing for the y. Okay, Control V, y, and then do the y here, and instead of cosine it's sine, and then I will draw a line from x comma y to offset x comma offset y. So I'm not drawing the lines anymore from the point to the individual foci, so I can just get rid of those, so it's not adding to the confusion. Alright, draw a line from the point on the ellipse. That would be down here. Cut. And that would be paste. Okay, and let me see if I can clean this up a little bit before I go on. I don't necessarily need to be sleeping here. And I want to sleep after I print the line there. So I got one sleep, to sleep. I don't need to sleep right there either. Where else am I sleeping? Alright, ready? I should be sleeping. Right? I should be sleeping. Okay, so it drew. I should get rid of this. I should get rid of this outer circle so you guys don't get confused. Where am I drawing that outer circle? Right here. Delete, save, and run. Okay, so the first point on the ellipse, it is drawing a line at the bisector angle, and the length of the line is the drill bit radius, which is set to 20 millimeters. So I will then press space on my keyboard to move over to the next one, and it drew a line, you just can't see it, and drew another line, and so forth. What we can do to make things a little bit easier, instead of drawing lines, I can go like I can just go, oh, wow, I don't know why it does this sometimes. I can just go P-set, copy, paste, P-set, P-set. But not draw a line. Comment that out. Save, run. You're not going to be able to see it really well. It's got a little tiny dot right there. So let me get out of that, and instead of going in my 4 next loop, instead of going every 45 degrees, let me go every 1 degrees, from 1 to 360, and then save and run. Here we go. So now you can kind of see, whoops, that's not going to work. Alright, let me just go all the way through it. Let me take out all of these print statements. Hold on a second. Take out all these print statements and possibly the sleeps, okay? So print and print and print. Sleep, take that out. Let it go all the way around. Okay, so there's all the points on the ellipse, and you can see those little tiny dots right there represent the drill bit path. If you were to take a drill bit and put that drill bit right there, like, let's see, where's my paint at? So okay, so you have an oval, and then you have a drill bit. And I want that drill bit to be going right there. It won't let me move it, huh? So the center of that drill bit is going to be following these little tiny dots. See all those little tiny dots right there? The drill bit is going to follow on the center of the drill bit is going to follow on those little tiny dots, while the outer edge of the drill bit is going to be drilling right there against that piece of wood. So when you get done drilling this all out, you're going to have a great big hole, you know, right in the middle right there. And if you wanted to do it on the outside, then what you got to do is if you wanted to do it on the outside, then the bisector angle right here, whatever the bisector angle is, just add 180. Bisector angle plus equal 180. Uh-oh. What did it do? Okay, save. Save. Okay, so now it's drawing the path that the drill bit is going to follow on the outside of the ellipse. So the drill bit is going right there on the outside. That would be where the drill bit is right there, see? It's going along the outside. And it's cutting away the wood. So the edge of that, when it gets done cutting all of it out, you're going to have an ellipse. And it's following the path, you know? Following the little path. Those little dots. Following those little dots. So there you go, guys. I hope that really helps you understand.